Good morning, good afternoon, or good evening, depending when you're watching this lecture, students. We are going to be diving into one of the last three lectures that we have in this class, which is about experiments. So we're going to be talking about the ways that we conduct experiments and look at the world around us, right? So without further ado, let me move myself on the screen. Let's get into it, shall we? So as I said, we're going to be looking at experiments, right? So this week we are looking at those set experiments, which most simply involve the researcher taking some sort of action, then observing the consequence of said action. All right, in the classical experiment, we have the independent variable, aka IV, and the dependent variables, DV, right? Where the independent variable is either present or not present in the study, right? Then we see if it has an effect on the dependent variable, right? We do this first by presenting the participants to get measurements of the dependent variable, then expose them to the independent variable, which is the stimulus. Then protest them to see if there is a change from their initial pre-test measurements, right? So we post-test them to see if there's a change from the original pre-test measurement. Cool. Sounds simple, right? We also would want an experimental group and a control group. It's very important to have these so that we can do kind of cross comparison, right? The experimental group gets the stimulus, the control group does not. So then you can compare to see if these experiments can actually had an impact on the said experiment or the study. Yeah. So let's say that we wanted to introduce research methods class as a variable that would aim to add more connection to the course, right? This example is more in line with an experiment from an evaluation research that we will learn more about soon, which actually measures a real intervention put into place. In any case, let's say that we would implement mandatory Zoom office hours, right? So let me just move myself here so we can look at this experiment that we're conducting, right? So we're implementing mandatory Zoom office hours for students and the instructor to discuss the concepts and get to know each other a bit more, right? Little professor-student contact to be able to make you feel more close, I guess. That's the idea, right? The independent variable will be the office hour. The dependent variable is connection. Well, the hypothesis, aka requiring a Zoom office hour, will increase connection for course members. That is, connection between the course members will increase with the requirement of the said office hour attendance. We would have one class experimental group that gets the independent variable and required office hour, and we would have another class would be the control group, and then not add the office hours, right? We'd first pre-test everyone to get a baseline of how they connected, or how they feel, and then we would hold the class with an office hour requirement and then post-test everyone again and see how connected they feel. Essentially, we're looking at how this impacts it, right? If there was a greater connection in the experimental group, we would be able to confirm that adding an office hour indeed impacted the connection to the in-course. This would be the goal, right? So understanding that you need to have that independent variable impact the dependent variable, super important. Adding office hours to a class to see if connection works and then be able to have one with and without shows us kind of if it works, doesn't work, if it's circumstantial, with it happenstance, it matters, right? So then let's look a little bit further here, right? Let me adjust myself because there's a lot on this slide. Yeah. So in lab experiments, we often see a double-blind studies, which aims to eliminate reactions that can manipulate the results, which we have already studied as the Hawthorne effect, right? We talked about this earlier. Double-blind means that both the participants and the researchers do not know who is in the experimental group and who is in the control group. The reason for this is that way the researcher treats all participants the same, essentially trying to remove that bias. For example, this standard for testing new medical research, such as a pharmaceutical drug, the medical researcher won't know who receives said drug, right? And who receives said placebo, which limits the researcher from being able to be biased when administering the drug and examining the participants. If you've ever had to watch a silly show about this, if you ever had to watch or wanted to watch a silly show about this, there used to be one back in the day. I don't know if it's really aged that well. That was called Testes. It was funny at its time for the idea of this, but maybe more inappropriate nowadays. But essentially, a good thing to watch if your style of humor is this kind of cringe idea of those who do these types of test groups, right? Just kind of a funny little one from me to you. We want to select the participants to be in the control group versus the experimental group in a way that so all of our participants have an equal chance of being in the experiment or in the said control group, right? Basically, we aim to get both groups to be as similar as each other as possible. Therefore, we don't rely on the convenient samples that usually use available subjects for studies. We want to use probability sampling so that we can get a representative sample that can be generalized to the larger population that also mirror each other in both experiment and control group. So it's really important to be able to do these said things, right? So it's really important how we build these out, right? If we have a large enough group, we can simply randomize the subjects by numbering them and sending half of the control group and half of the experimental group. We could instead use the matching technique that can help to get more similarity between the two groups. We'd need to decide the criteria for the matching, sorry, which is similar to how a quota or stratified sampling is done, which we learned about in the previous modules in sampling, right? So let's say age and sex are important for us to identify, as we want to have equal representation for men, equal representation for women, and equal representation of those young and old in each group. Perfect. We'd separate the list into men and women, uh, if we're only doing it based on the original binary, right? Then separate each of those categories into whether they're younger or they're older. So from there, men and women, young and old, we would randomly select people from each to go into the experimental group and the control group. So let's just say for numeric reasons, we have 10 young women and we put 5 into the experiment and 5 into the control. And let's say that we have 12 young men and we put 6 into the experiment and 6 into the control, and we continue with the other categories for the older and younger men and women, right? So we are matching the characteristics, then pairing people off and having similar characteristics. One goes to the experimental group and the other goes to the control group, yada, yada, right? So instead of simply randomly selecting from a large group, we make sure we have more similarity if we first characterize the people before assigning them to a group, right? So that's a lot of stuff. Hope that makes sense, right? The reality behind this is that we don't just want to do standardized versions of this, right? We don't just want to have a select from a large group. We could end up with several more women in the experimental group and only a few in the control group, where the control group may have more male representation, for instance. While we generally think of experiments as happening in the lab and clinical settings, that is set up with these strict standards of double blindness, rigorous sampling techniques, and with pre and post testing to examine the experimental results, there are several other variations of experimental designs. We have the idea of pre-experiment research design, do not meet the scientific standards of the classical experiment, and may need to be used if not possible to set up a full experiment. They may be missing a control group, a pretest, or both. A one-shot study case only gives the independent variable, as you can see on your screen here, right? So only get the independent variable stimulus to one group of subjects and tests what happens, right? Without a pre and post test or a control group, we can't be sure if the IV independent variable actually influenced the outcome, or if that outcome would have happened anyway. So there wouldn't be any kind of reliability and validity, right? So if all of our students felt more connected to begin with, if we didn't pre-test and have a control group, we may assume that the required office hour worked, but it really was just because the students were really feeling strongly connection to the class already. The one group pre-test and post-test design has a pre-test but still doesn't have a control group, right? The issue that the pre-test itself here is a spurious relationship, right? We may find the outcome, but it could be from something else that happened and not our experimental stimuli, right? So maybe something happened in the news one day and brought the class together and to feel more connected, right? And the static group comparison does have a control group, but no pretest, right? In the design, we would know if our other groups are similar enough. That is, did our randomization or matching of the two groups work without a pretest? We don't know if each group has the same initial characteristics, right? Which means our results may be skewed because our groups are different from each other rather than results coming from the experimental stimuli, right? Or stimulus. Maybe our experimental group just happened to include more people who felt connected than those in the control group starting. This really matters when we're looking circumstantially at the situation, right? Do we have a one group pre-test, post-test design, a static group comparison, a one-shot case study? These are all things we have to consider when building surveys or having an understanding or doing experimental designs, right? We need to make sure that these things matter and that we're looking into them, because we can't have spurious relationships or outside stimuli that we don't know changed it, because then we don't really get an idea. We don't get the gist of the position, right? Going from there, right? Experiments do not only need to be conducted in a lab setting, as mentioned earlier. In the social sciences, going out into the real world, touching grass, right, is useful for conducting experiments in settings where these are called where there are people. These are called field experiments, as you can see in your slide. We also may have natural experiments, which also happen out in the real world. Yet instead of the researcher setting up the stimuli that is choosing the independent variable to cause an outcome, something in nature or a social event outside of a controlled setting may have done that for us, right? So it's done for us. So studying an affected area after a flood or a fire and assessing the damage, that's happened a lot recently. Who was impacted, who wasn't? Is it an example of this or that, right? One major concern, though, is that the researcher might just take what happened and can't after and find out additional information. We also have the internet to use as a setting for experiments, right? The Harvard implicit bias test. If you haven't taken it, I encourage you to take it. It's hard because it really will show you where you have biases, but this is an example of an internet-based experiment, right? Where participants test the hidden or underlying biases towards people who are different from themselves, with a series of pictures and words, clicks on the keyboard. The experiment, such as A/B testing or split testing, is used largely in user experience research that is conducted on new technological programs and products. I use these in classes all the time. I'll do one class with this test style, one class with this test style, use this book in this class, use this book in this class, and see if the students have a better reaction, right? I'm A/B testing to see which is more effective. So if you want to test your new website design, if it works or doesn't work, you would set up two samples, right? An A and a B, and then collect data from your randomized or matched participants on the two variations and see which design is better or which class is better, which book is better in my situation, right? There are some validity issues when considering the experimental research method, right? Invalidity is when the experiment or any method is not valid. That is, it is not accurately displaying what really happened. There are reasons that can cause invalidity internally within the experiment itself, right? Internal validity, right? And so these conclusions that we may come to may not actually accurately reflect what went on in the experiment. As we've talked about, there are some of these issues already when it comes to the selection bias, things we choose, right? If we choose subjects that don't match each other for the control versus experimental group, we can't be sure our experiment is even valid. For the comparisons might not have meaningful results if we don't have similar groups from the start. Right, something else might also come up that happens outside the experiment that impacted the spurious relationship, right? And we might not measure or test accurately. These are all things that happen internally, right? So internal validity, the experiment itself, so that our results may not be accurate. External validity occurs when we can generalize our results to the outside, the real world beyond the experiment. For example, we may have gotten our results because the experiment, and we wouldn't get those same results in the real world. Our pre-test connection to the classroom could actually get our students thinking about the issue more, so they become more sensitized to it, right? Which then makes them want to participate in the office hour. But in any other class, they may not have the same outcome. Therefore, it can be problematic or cause a change to it, right? This is the external validity. Your slide's not been changed to kind of look at this, right? So that there's a reality if we're looking at things. We have to always be measuring, right? Go back to the slide to get kind of ways to look at this type of validity in issues, right? So there's strength and there's weaknesses, right? This is how it works. The limit to the risk of having a pre and post test or pre-test influence the outcome of the experiment. The researcher could use methods referring to the Solomon group design, for instance, right? This takes four different perspective groups and compares control groups and without pretest. Blah, it's hard to say. There are some strengths and weaknesses. The ethical concerns of conducting experiment. A large advantage of experiments is that we can isolate the experimental variable and come to a causal conclusion, right? Or allows us to understand. If we know the start of the group and has certain characteristics, then we introduce the independent variable, the stimuli, and then the characteristics change. As long as there is no additional stimuli, we can assume that the independent variable caused the dependent variable to change. We can also replicate experiments several times using different groups of participants, yet we must contend with artificiality, right? Especially in the lab or the clinic. And what happens in the lab may not happen in the natural circumstances. Field experiments are harder to control. And we must also complete with the Hawthorne effect. That is, the participants know they are part of an experiment. They may behave differently than they would in the usual world, right? Ethical connections are also a weakness. Experiments must always involve deception because the researcher is introducing an action only to one group to see what happens. It is important to determine whether the deceiving participants is essential to the experiment and whether the value of what may be learned from the experiment justifies the violation, right? So you need to figure out that's your good move there. So it's important to make sure if we use deception that we are following ethics. Experiments almost always involve deception, right? It's the most important term if we need to. And then the reality is that when we do these things with ethics, debriefing is essential for the explanation for the participants after the fact and limit any damage to the person. Reviewing the section on research ethics from our earlier module may be helpful to recall the concepts and how experiments have gone wrong in the past without institutional review boards, IRBs, right? Taking steps to limit harm to the human subjects. So essentially, remember, it's essential to protect the participants in whichever research method we employ or way that we conduct experiments. We are always focused on protecting our participants because we do human-centered research in the social sciences. We work with humans. And I will see you all in the next experiment. I'm sorry. I'll see you all in the next lecture. That's all for now.